So for number 19, f of g of x, g is the inside function, so we're coming in with all the real numbers. So we're going to put this one in here. So then that gives you square root of x plus 3 minus 2. So simplify that, gives you square root of x plus 1. So that's the f of g. The domain for this one is all x such that x is greater than or equal to negative 1. Okay, for part B, it's the reverse order, g of f of x. So that means we're coming in with all real numbers greater than or equal to 2. So we're going to put this one here. So that's going to be square root of x minus 2 plus 3. Now 3 is on the outside, so you cannot combine 3 and the negative 2. So this is basically the answer. You can't do anything else with it. So the domain would be all x such that x is greater than or equal to 2. Okay, so 20, we're adding the two functions together. So we're adding 3x squared minus 6 plus x squared plus 4x minus 2. So that gives you, add your like terms, so that's 4x squared, and then there's only one 4x, and then there's that negative 6 and negative 2, so that's negative 8. Okay, so we're subtracting g minus f, so notice I put them already in the right order. So that means that we're going to change the signs of the second polynomial, so this becomes negative 3x squared plus 6, because we're distributing this negative. So now combine like terms, so you get negative 2x squared plus 4x, and I've got a 6 and a negative 2, so that's plus 4. Okay, 20C is a multiplication problem, so I like to make like a little grid like this, and just multiply each term. So this is 3x to the 4th, 12x squared, to the 3rd, negative 6x squared, and then you go to the next row, negative 6x squared, negative 24x, and positive 12. So you combine your like terms. So I got 3x to the 4th plus 12x cubed. I've got this one and this one that are squared, so that's minus 12x squared minus 24x plus 12. So there's the answer. Okay, so for D, it's f over g, so you just put f over g just like I have on the screen. There's nothing, I can factor out a 3 up here, but it's not going to simplify with anything down here. So I'll just leave it like that. For letter E, they want you to find the domain of f over g. So what that means is we want to find what makes this 0, okay, so that we can exclude it from the domain. Okay, whatever makes it 0. Now, unfortunately, it doesn't factor. So you're going to have to go back in your memory Rolodex and bring up the quadratic formula. That's the only way to solve. So remember, it's negative b plus or minus the square root of b squared minus 4ac all over 2a. So push up a little bit. Negative b would be negative 4 plus or minus the square root. B squared would be 4 squared minus 4 times a times c all over 2a, which is 2 times 1. So inside the radical, I get 16 plus 8, which is 24. And so 24 is 4 times 6, right? It's 4 times 6. So the 4 comes out as a 2. So I have negative 4 plus or minus 2 radical 6 over 2. I'm going to factor out a 2 from the numerator. Remember, only the outside numbers, not the inside. And so that will allow me to cancel out the 2's there. So then x equals these two numbers. Because remember, these are two numbers. negative 2 plus radical 6, and negative 2 minus radical 6. So in your answer for the domain, you would say all x such that x cannot equal negative 2 plus or minus radical 6, because those two numbers would make your denominator 0. Okay, for letter F, we're going to do g minus f of negative 1. So that means that we have to do g minus f and then replace the x's with negative 1. We're evaluating at negative 1. Now, the nice thing about this one is that we already solved g minus f up here in problem in letter B. So it's negative 2x squared plus 4x plus 4. So negative 2x squared plus 4x plus 4. Just make sure. Yeah. And so you find, replace the x with negative 1. So negative 1 squared is 1 times negative 2 is negative 2. 4 times negative 1 is negative 4 plus 4. So this cancels, so you have negative 2 as your answer. So for letter G, we already have the answer for f times g back in letter C. But let me just show you another way of approaching it. We could do f of 3 times g of 3. Same thing. You'll get the same answer. So f of 3 means you're going to replace the x with a 3. So that's going to be 3 times 3 squared minus 6. And so it's going to give you 27 minus 6. So that's 21. And then you do g of 3. So g of 3 is 3 squared plus 4 times 3 minus 2. So that's 9 plus 12 minus 2. So that's 90. So then you take the 21 times 90, and that'll give you the answer. Okay, so for 21 through 25, we're finding the inverse, and you guys asked for all of them. So switch the f of x to y. Then we switch the x and the y. Then we solve for y. So I'm going to go ahead and divide by 2. And I need to get rid of the radical, so I'm going to square both sides. By doing that, I get x squared over 4 equals y plus 1. So now I'm going to subtract the 1. So then y equals x squared over 4 minus 1. And so just write it in function notation. And that would be the inverse. Number 22. Changes g of x to y. Switch the x and the y. Solve for y. Whoops. Plus 8. So then I have x plus 8 equals 3y. I'm going to divide by 3. And so now I have y by itself, right? So I just write it in function notation. And that would be the inverse right there. Okay, so h of x is y. And I'm going to switch the x and the y. So now I'm going to solve for y. So we subtract 4. So that gives you x minus 4 equals negative 3. Okay, now I'm going to divide by negative 3. So that leaves that. Now I'm going to take the cubed root of both sides. Okay, because I've got to get rid of that radical. So cube root of both sides. So all those 3's get confusing. So now I have y minus 1 equals, I just switched the sides, but it's the same thing, right? This. And I'm going to add 1 to both sides. I just put in the front, okay? But it's the same thing. And write it in inverse notation. Now, usually we don't keep negatives in the denominator, so I can actually take it out because the cube root of negative 1 is negative 1. So I can take out this negative out, and so it would become 1 minus cube root of x minus 4 over 3. So that would be the inverse right there. Okay, so switch out the r of x for y. Switch the x and the y. And so I want to solve, I want y by itself. So what I'm going to do is I'm going to multiply by y to get it out of the denominator. Then I'm going to divide by x. So I end up with y equals, oops, I put 3, sorry, divide by x. So that's gone, 3 over x. So that's the inverse. So this is one of those where the inverse and the function are the same. Okay, number 25. P of x equals 2x minus 1 over x plus 2. So P of x becomes y. So if you notice I'm saying the steps as I go along, it's the same 4 steps over and over again. Switch the x and the y. And solve for y. Now this one I've got to create make it a proportion so that I can cross multiply so that it's easier for you guys to see it this way. So this means x times y plus 2 equals 1 times 2y minus 1. So xy plus 2x equals 2y minus 1. Now I'm solving for y, right? So you have to keep that in mind. So I'm going to put all my y's on the same side. So I'm going to take this one and move it over here, and this 2x I'm going to move out of the way to the other side. So xy minus 2y equals negative 2x minus 1. Now I'm going to factor out the y because I want to isolate it. So the only way to isolate it is to factor it out of both terms. Okay, so now I could divide by x minus 2. Now x minus 2 is gone on this side. And so there it is. P inverse of x equals negative 2x minus 1 over x minus 2. Now I could factor out a negative from the numerator and write it as 2x plus 1 like that over x minus 2. So either one's fine. Okay, for 26 you have to show that these are inverses of each other and you have to use composition for that. Okay, so we're going to do f of g of x first. So I'm going to take this function and substitute it in for the x here and here. Okay, so x over 1 minus x over x over 1 minus x plus 1. So here's where the x's used to be on the f of x function. So I need a common denominator right here. This is 1 over 1. So I'm going to multiply by 1 minus x over 1 minus x. So now I could combine, let me just write the numerator again. I can combine these two guys. So x plus 1 minus x, the x's cancel out in the numerator, so I'm left with 1 over 1 minus x. When I simplify this, remember this means x over 1 minus x times the reciprocal of the denominator. So the 1 minus x is gone, so this leaves me with x. So now I do g of f of x. Okay, so that means that I'm going to take this function right here and replace it for that x and for that x. So it's x over x plus 1 over 1 minus x over x plus 1. Okay, so I need a common denominator. So I'm going to multiply the 1 by x plus 1 over x plus 1. Simplify my denominator, and let me just write down the numerator real fast. So 1 times anything is itself, so that's not going to change. So x minus x is gone, and so I'm left with 1 in the numerator. So this is x plus 1. So when I simplify this, I get x over x plus 1 times the reciprocal of the denominator. So the x plus 1 cancels out, so I'm left with x. Now, since both compositions, f of g of x and g of f of x, gave me x, then this shows that f and x are inverses of each other. Okay?